If we do not have an initial estimate for p hat, use p hat equals 0.5 because that produces the largest margin of error. That means that you'll be as conservative as possible in your choice of n, and if p is something different to 0.5, your n will then definitely cover the situation you want. Now, the reason this works is because the standard deviation contains 0.5 times 0.5 divided by n. The 0.5 times 0.5 is the largest that the product p, 1 minus p, can be. To illustrate that, this is a graph of y equals x times 1 minus x. For values of x between 0 and 1, of course, p has to be between 0 and 1. And you can see that if we do a g-solve for the max, that happens when x is 0.5. So now we're asked that organisers are trying to decide on a venue for a visiting speaker at a university. How many students should be surveyed to establish the preferred venue at an error margin of 5%? So that means that E is 0.05 and a confidence level of 90%. Now what we're going to do here is, of course, take p hat to be 0.5 as discussed. So let's do this using the E activity. So z-score for CI, we're doing a 90% confidence interval, so 0.9, and solve for Z. Then go to our sample n for confidence interval. This time our p is 0.5, our e is 0.05, our z value is in there already, and we get that n is 271. If the p is something different to that, it's fine. The 271 will cover it.